Okay, we're at guide sheet number 2, the second part. We're talking about wave interference. These are objectives 4.5.5 and 4.5.7. First, some basics, some true and false, to get some idea of how these things work. When two pulses meet up with each other while moving through the same medium, they have a tendency to bounce off each other. That's definitely false. Think about that. If it was true, then every time you tried to look at somebody else, your waves would bounce off of theirs and come back to you. You'd only see yourself. Constructive interference occurs when crests meet up with another crest at a given location along the medium. That's true. Constructive is when two similar or in phase waves are going to meet. Destructive interference occurs when a pulse with a plus 5 units interferes with a pulse with an amplitude of minus 5 units. That's also true. They're in different amplitudes, different phases. They're going to have a tendency to cancel each other out. Destructive interference occurs when a trough meets up with another trough. Would be false. That would be constructive. If a pulse with an amplitude of plus 5 interferes with a pulse with an amplitude of plus 3, the resulting amplitude will be plus 4. The average is false. It's simply going to be the sum. So it's plus 5 plus 3 would be 8 units. If a pulse with plus 5 interferes with a pulse with amplitude minus 3, then neither constructive or destructive interference occurs, and that is false. We have a plus and a minus, so they're going to add up to plus 2, which is smaller than either of the other two unit sizes, so it's destructive. Two sound waves can interfere in such a manner to cancel each other out, and that's definitely false. Bose make some great headsets that cancel sounds out that are coming in. You can actually use outgoing sounds to cancel out incoming sounds, so definitely a possibility. Alright, so 4.5.5 says state the principle of superposition and explain what is meant by constructive interference and constructive and destructive interference. Well, here they are right here. The effect of two interfering waves upon a medium is to produce a resulting shape and size that is a combination of the shapes and sizes of the individual waves. So if those build to create a larger wave, then we say it's constructive interference. If they build to create a smaller or no wave, then we say it's destructive interference. So here are the first two waves coming at each other. When they meet, here's where they're at. Now they both have an amplitude of plus 1, so the actual wave that they would create would have an amplitude of plus 2, and that would be constructive interference because it built to make a larger wave. Here we have a amplitude of plus 1 and an amplitude of minus 1. They actually add up to 0, so the overall, when they met, they would cancel each other out and there'd be no wave at all. That's destructive. We've reduced the overall wave energy. Now, again, this is only occurring while they're in the same place at the same time. They will pass right through each other and then continue on, and the energy does not disappear. We can't, again, conservation of energy, you can't have energy just disappear. It's only temporarily during the interference that it's being reduced. Here we have a 2 and a 1. Now 2 and 1 adds up to make a total of 3. So this would be one wave that was at plus 3, and that's constructive because it's gotten larger. In the next one here we have negative 2 and plus 1, so their combination is going to end up making a negative 1. Now negative 1 is smaller than the negative 2 that we started with, so this is destructive. Let's reduce the overall energy at that point. Now those are just pulses interfering. We can have exactly the same thing happening when we have a wave, continuous wave form. And we can approximate the shape of the third wave by looking at some of these points. Like here's point A. It's 2 plus 4, that would be at 6. So the principle of superposition says I'm just going to add the two waveform sizes. This is 3 and 1.5, so that's 4.5. Here at point C, it's negative 2 and negative 4, so that's negative 6. Here at D, that's positive 2 and positive 4, so that's positive 6. Here it's 0 and 0, so that's 0. Here it's 1 and 3, so it's about 4. So far this wave is looking something like, I kind of missed, but something like this, the combined wave of the two. If we continue on, we just get the same repetition of an interfered wave that is about amplitude of 6 as opposed to an amplitude of 4. Okay, so we build a bigger wave. Now with the second diagram, they're not, let's see, we could call these two waves in phase. They're at the same, their peaks are at the same point, at the same place, or at the same time. These two are not in phase, so it becomes a little bit more complex. It doesn't form a nice, clean, brand new, larger wave shape. It forms something a little more complicated. It's actually, in sound, we call it a beat. So there's, at point G here, I'm at 1.5 and 4, so I'm at about 5.5. Point H, I'm up 1 and down 4, so I'm around 3. Here's another 0, here's another 0. These are both 0, 0, and 0, 0, and 0, 0, so those are all points. Here is a negative 1.5 plus 4, so that's about positive 3. Here we're at negative 4 and 1.5, so we're up to about, let's see, 4 plus 1.5 would be about 5.5. So now you can see this wave shape is taller. There's another 0 point, so I gotta go down to that 0 point. Then shorter, then still shorter, but now notice it gets taller, and then we're going to have the same kind of process build. It's going to be then taller, cancel a little bit here, so shorter, taller, cancel a little bit, so shorter. These two are going to act together to make it taller. These two are going to act together to make it taller. So it's going to be higher here, then lower. I kind of overshot my 0 point. Then up, then taller, back through 0, and then actually shorter again. So we have a tall wave, then a short wave, and a short wave, and then a tall section, then another tall section, a shorter section, tall section. So the wave is a little bit more complex than it is for diagram A. In terms of whether it's constructive or destructive, the A are adding together, so that's going to be constructive. B is adding together, so that's going to be constructive. C is adding together, so that's constructive. D is adding together, so that's constructive. E is adding together, so that's constructive. Okay, now it does make it a larger negative. It's not about the negative, it's about did the new wave get bigger than the older waves. And F is also constructive. Those are all constructive points. Those waves are in phase, so they're all going to have constructive interference. Now with the second half, G, the two are constructive. They're in the same direction. And at H, they're also constructive because they're both down. See, at I, now here we have a down and an up, so that's actually finally destructive. J, they're both on the same side. Notice they're both on the same lower side. That's the easiest way to pick out. Oops, sorry, that's constructive, not destructive. If they're on opposite sides, then they'll be destructive. At K, they're on opposite sides, so K is going to be destructive. L, they're on opposite sides, so that's going to be destructive. M, they're on the same side, so that's going to be back to constructive. And then N, they're on the same side, so N's back to also constructive. And then O, they're on opposite sides, so that's going to be destructive. Okay, so if they work together, it's going to be constructive. If they work against each other, then it's going to be destructive. So our final pictures in color here, the purple is the result, purplish, is the result of the green and the blue. And that's constructive. At every point, the two waves are on the same side of the equilibrium position, term I should use more frequently. This is the key element here. This is the equilibrium position. This is where we would be if there was no wave energy. So here, both the green and the blue are on the same side, so they're constructing to build a larger wave. Same thing here. They're just constructing to build a larger negative wave. The resultant here is actually 0. The two waves are now on opposite sides of the equilibrium line, so when they add together, we get a plus and a minus, and they add up to 0. So the overall result here is no wave at all. Those two waves are canceling each other out at that point. Now again, they would pass through each other, and then there would be no impact once they made that pass through. So even though light waves are interfering all in between you and seeing another person, the end result that reaches your eyes is what left to them. If you had some things that cause the light to change direction, like heat rising in the atmosphere, that can cause a waving in what you see. So stars twinkle because of that effect in the atmosphere. If you were out in space without the air in between you and the stars, everything would shine perfectly brightly with no twinkle. Okay, so that's the basics of superposition, and we've applied it to a couple of different waves to show how it could be constructive or destructive.